This example comes out of section 2.5, the quotient rule. We're asked again to find the derivative. We're told that y equals the square root of x over 7 plus 4x squared, and we're asked to find dy by dx. I personally prefer exponents to radicals anytime I'm doing derivatives, so I'll leave it looking like this. And my derivative, if you recall the quotient rule, says it's the bottom function, 7 plus 4x squared, times the derivative of the top, so 1/2 x to the negative 1/2, minus the top function, times the derivative of the bottom, 8x. All of that divided by the bottom squared, 7 plus 4x squared. Again, now if they would have just asked me for the slope of the tangent line when x equals 2 or something, I could just put in x equals 2 and find that slope right now. I don't have to do any further simplifying. If the question says find the derivative and simplify it as much as possible, which your assignment and your test will make you do to a certain extent, you better do a little bit more on the top here. The bottom, again, is fine. The top, I've got a bit of ugly terms here. I'm going to have 7 over 2x to the negative 1/2. I've got plus 2x to the 3 over 2, and then I have minus 8x to the 3 over 2. And hopefully you can see that there's a reason why that was a valid step here. At the bottom, again, I'll leave it as 7 plus 4x squared. I have some like terms on top. So if nothing else, I should be able to say I've got 7 over 2x to the negative 1/2 minus 6x to the 3 over 2. Those guys can go together, and I have over 7 plus 4x squared. Now that numerator I can make look a little bit nicer by factoring it, and I know how much you all enjoyed doing this in pre-calculus, so I'll practice it here with you as well. If I take out a 1/2 and an x to the negative 1/2 in the numerator, the reason that is a useful thing to do is take a look at what I have left here. I have 7 minus 12. So we have, once this thing is factored, the 7 minus 12x squared over 7 plus 4x squared in brackets squared. Last thing you might do, or probably should do, is realize that this 1/2 x to minus 1/2, both those things can go in the denominator, so you're left with just 7 minus 12x squared on top, and you can say 2x to the 1/2 times 7 plus 4x squared on the bottom. The reason why that form would be preferable to either the two that were above it is that it wouldn't be too bad then to figure out what makes this derivative equal 0, what makes it positive, what makes it negative, which turn out to be very important things coming up later in problem solving. So getting these things factored and simplified as much as you can is something we'll keep practicing, because it does take quite a bit of practice.